Yes. So, hello everyone. My name is Abhijit Akolkar, and I am from Pimpri Chinchwad College of Engineering, Pune, and presenting this slide to you as a microwave oven simulation. Uh, in the last month, I have completed the internship at Emertex Technology, and I will say that my experience is really good. The teaching quality and the other uh, contents are really good. The teachers teached very nicely to us, and yes, they took the we basically learned the embedded C language uh, and different concepts of different concepts in embedded systems. So that's what I'm presenting in this slide. So let's take a look at that. So what we can what we will see in this slide. So we will see the block diagram of microwave oven. Then we will see its working. Then we will see the project that we have done in this internship and what is its requirements, what the components are required in the microwave oven. Then I will show the project simulation that I have performed on the uh, PixSimLab and the MPLab IDE. Then I will show the results, then application of microwave oven, and the conclusion of this project. So let's start it with the introduction. So introduction starts with the basically a microwave oven. So what is microwave oven? Microwave oven is the an appliance that cooks or warms up the food using microwaves produced by an electronic vacuum tube called a magnetron. So microwaves can be used in cooking because of certain characteristics. They pass through many types of glass, plastic, ceramic, and paper. So coming to the next slide, we see this block diagram. So and we have mm, we have built our program in embedded C, and that embedded C program works on this block diagram. So let us see how this block diagram works. So first, when we will switch on the microwave oven, the display will be on, and the light inside that microwave oven will glow. And then when we put a ball inside that microwave oven, we will set the timer. After the timer is set, the door will be closed, and after the door will be closed, the food get heated. How we will see in next slide how the food is heated. But in this block diagram, when the food is heated, the timer goes off, and microwave oven goes to its ideal position, and then we will switch off the button. So coming to the next slide, the working of microwave oven. So basically a microwave oven, we we just see that microwave oven is an appliance that cooks or warms up the food using microwaves produced by an electronic vacuum tube called a magnetron. A magnetron converts electricity to electromagnetic radiations, which we call the microwaves, which is made up of waves of electric and magnetic energy. Once generated by a magnetron, microwaves travel through metal enclosure called a waveguide to a stirrer fan, which distributes the microwaves into the cooking cavity. So inside the cooking area, the microwaves are absorbed by the food, which is cooked or heated in a few minutes or seconds. So what are the project requirements that we have used in this project called microwave oven? So we have used PIC microcontroller. We programmed in embedded C language, and we have programmed embedded C language in the MPLab XIDE and simulated in the PixSimLab software. So let us see that. So microcontroller. A microcontroller, which is called MCU for a microcontroller unit, is a small computer on a single metal oxide semiconductor, which is also called as MOS, integrated circuit IC chip. In this project, I have used PIC 16F BX8778. It can be write erase as many times as possible because it uses flash memory technology, and it has a total number of 40 pins, and there are 33 pins for input and output. PIC16F8778 has many applications in a huge number of devices. Now coming to the Embedded C is the most popular language in software field for developing electronic gadgets. Each process used in electronic system is associated with embedded software. Embedded C programming plays a key role in performing specific function by the processor. Now, embedded C language is performed on MPLAB XID and PixSimlab. So, what is a MPLAB XID? MPLAB XID is an expandable, highly configurable software program that incorporates powerful tools to help you discover, configure, develop, debug, and qualify embedded designs for most of our microcontrollers and digital signal controllers. Then, coming to the PixSimlab, PixSimlab is a real-time emulator of development boards with integrated MPLAB X debugger. PixSimlab supports some PixSim microcontrollers. PixSimlab have integration with MPLAB X or Arduino IDE for programming the board's microcontrollers. Now, what what components or what to, it, in which components we have programmed in embedded C, or what components are used in a microwave oven? Let us see that. So we can see that various components are needed, like LED, tactile key, matrix keypad, interrupt, timer, CLCD. So let us see that. So coming to the LED, we all know that LED means a light emitting diode, which is a semiconductor light source that emits light when current flows through it. So light is produced when the particles that carry the current, which are known as electrons and holes, they combine together with the semiconductor material. As we can see in the diagram, it consists of two terminals, namely anode and the cathode. As its name suggests, it is a light source that emits light when we apply a voltage across its terminal. We usually use it as an indication signal in embedded system projects. Now the tactile switch. So tactile switches have a small tactile bump that provides resistance which can be felt at the point of key actuation. Tactile switches are versatile performers that cope well with a variety of different typing tasks. So matrix keypad is again consists of tactile switches that we have seen now, which uh, which is a small compact input device that accepts the user inputs and processed by the microcontrollers. The advantage of matrix keypad is that the use of it will allow the programmer to reduce the number of pins to be used. In a 4x4 matrix keypad, there are 4 rows and 4 columns connected to 16 push button switches. And this logic we have used in our embedded C programming. Now coming to the interrupt part, an interrupt is a signal to the processor emitted by hardware or software indicating an event that needs immediate attention. Whenever an interrupt occurs, the controller completes the execution of the current instruction and start the execution of an interrupt service routine, which is called as ISR or interrupt handler. So PIC microcontroller consists of both hardware and software interrupts. If the interrupts are generated by the external hardware at the certain pin of microcontroller or by inbuilt devices like timer, they are called hardware interrupts, which software interrupts are generated by a piece of code in the program. So timers is one of the interrupts, and we have programmed timers also in the microwave oven, as they are one of the important uh, they perform one of the important function in microwave oven. So let us see the three function of timers. So as the name suggests, these are used to measure the time or generate the accurate time delay. The microcontroller can also measure the required time delays by running loops, but the timer or counter relieves the CPU from that redundant and repetitive task, allows it to allocate maximum processing time for other tasks. PIC 16877A has three independent timers, namely timer 1, timer 0, timer 1, and timer 2, which can be used as timer counters or for PWM generation. Now let us look at the CLCD part. So what is CLCD? CLCD is a character liquid crystal display, which is better known as CLCD, is an excellent way for a microcontroller to present visible information. CLCDs can display output from the microcontroller, such as time, date, and temperature. They can also be used to display the contents of the memory and aid in debugging programs. Now we will see the project simulation. For that, we will first I will show the MPLAB XIDE. So this is MPLAB XIDE and this is our project file microwave oven. So this is the program we have built in main.c. So you can see that we have coded CLCD, ISR, matrix keypad, timers.c files, and also for that we have programmed header files also, CLCD, main, matrix keypad, and timer header files. So let us build this project. Once build is successful, we can go for the simulation. So now I will open the PixinLab. I will load the file and we can see the output. Yes. So in this simulation, in the microwave oven, there are four modes, namely micro, grill, convention, and start. In the micro mode, I will show you the demo. First, the power is set to be 900 watts. Now we will set the time. So whatever we want to heat the food in whatever time we want to heat the food, we can set that. So for the timing, I will set the 10 seconds and we can enter that. As the timer is set, the clock runs down, and after the time gets completed, we get the sound, and we get the sound cooking timer, and our food gets ready. So like this, micro mode works. So in grill mode also, we can do like this, but in the convection mode we can set the temperature by at what temperature your food gets cooked. It's depending, so depending on us we can set the temperature. So we have set this convection mode. So let me go to the first page and show you the start mode. In the start mode, the timer set already set to the 30 seconds. So it will start from 30 seconds and will work for a small time. If you want to this extend time beyond 30 seconds, so you have to just start or resume the button. So if you press this key, the timer uh, the timer will uh, the timer will increase by 30 seconds. So so this is the working of this microwave oven. So after this, we have seen that after the timer is completed, it will be buzzer will be blown and it will show the cooking timer. So yes, and one thing we have also programmed, like, just I have to show this. I will open the micro mode. The power is set to 900 watts. Then if we set the timer as 25 seconds, I will enter. The timer will go. But if the door gets open, or anyone will open the door. So we have set that door key for this RB3. And now if anyone will open the door, let's see what happens. That's it. So if while cooking the door gets open, the buzzer will sound and you will get to know the door will be open. So this is the microwave oven project simulated on the Pixim lab and with using MPLab IDE. So let's come to the presentation part. Till now we have seen what are the components used in the microwave oven projects, how they work, and I have shown the project simulation using the MPLab IDE software and PiximLab software. So here are in this slide I have shown the results of that. So in the first image you can see that I have shown the various modes, different modes used in this microwave oven. In the in this I have shown that we can set the time, we can set the temperature, and this is the opening slide, opening of the microwave oven project. So yes, so now we will see what where we can use this. So definitely a microwave oven. We have built our microwave oven using the embedded C language and different simulation software. So what are the applications of this? We can use this in the reheating food. We can use this in cooking. We can use this in disinfectant kitchen items, making citrus fruits juicier, heating beauty products, perfume yeast, and decrystallizing honey. So that's it. Now we will come. Now I will come to the conclusion that a microwave oven is a very versatile kitchen appliance that offers a whole range of uses. And in this project, I have simulated the microwave oven by using PiximLab and MPLab XID and used different modes like micro, grill, convention, and start and shown the project simulation within the softwares. So thank you, all of you. Thank you.